from Hello World. This is Mona, your Unity teacher from the Underworld. Today, I will explain Unity life cycle. As every creature in this world has their own life cycles from birth to death, software also has their life cycle from the start to the end. Unity also has its own life cycle, as you'd face quite often while making your game. When you create a C# script file in Unity, it automatically inherits Mona behavior that includes predefined Unity events such as start or update. They are called event functions. So in Unity, when components or scripts are attached to a game object, they would perform their tasks in play mode. Unity has predefined event functions which are executed in built order. So let's start from the initialization part, which includes awake, onEnable, reset, and start. Here, in a script named Unity Lifecycle, I wrote 4 predefined event functions: awake, onEnable, reset, and start. Reset, which is only called when script is attached and not in play mode, is called immediately. Other functions are called in play mode in order. As you can see, Unity calls awake first, then onEnable, then start. When you set a game object active and inactive, only onEnable function is called. If a game object is inactive when it enters the play mode, none of the initialization functions are called. Then they are all called when the game object is activated. When a game object is active, but the script is disabled, only awake is called at the beginning, and onEnable and start is called when the script is enabled. When a game object is instantiated in runtime, awake, onEnable, start is called as usual. And then physics calculation. Fixed update, internal animation update, internal physics update, on-trigger series such as on-trigger enter, on-trigger stay, and on-trigger exit, and on-collision series, which includes on-collision enter, on-collision stay, and on-collision exit are calculated here. Then it will wait for yield, wait for fixed update if there are running coroutine waiting for fixed update. Fixed update is a useful event function when you calculate based on physics. Fixed update is called every fixed time step, which is different cycle than the frame rates. You can check the time differences by calling time delta time to check the time differences between the intervals. Here, you can see update has different time intervals each frames, while fixed update always has the same time intervals. And then the triggers and collisions are calculated. Let's compare on-trigger enter and on-collision enter. So here's a cube and there's a sphere with rigid body, which you always need for the physics simulation. At least one of the objects needs rigid body for calculation. There's a checkbox to make it as a colliding or triggering object. When its trigger is disabled, on collision enter is called. When its trigger is checked, on trigger enter is called each time the collider collides with another collider. Then there is wait for fixed update in coroutine, which is called at the end of the physics life cycle. Then there comes mouse input events, such as on mouse down or on mouse up, which are called on collider or GUI element. Then game logic follows. This part could be very useful or it isn't as useful as you might think. So update is called every frame. Then yielded coroutine would continue here. Then animation states will be updated. Then late update follows, which is also called every frame like update, but at the end of the game logic process. Update and late update could be very useful to detect certain inputs or calculate certain values each frames, but most of the time there are more efficient ways to implement the same function, so think twice before using update in your game. Update is called each frame. You can check it from time frame count function. Then yielded coroutine continues. If you add time frame count for update function and your coroutine, then you can see coroutine follows the update event. Then late update is evoked each frame but at the end of the game logic loop. Then after every changes are properly updated, then Unity start to render objects. The scene rendering part include functions such as on became visible, on became invisible, on pre-render, on render object, and on post-render. Let's check on became visible and on became invisible. These event functions detect when a game object is started or stopped to be rendered. Here you can check when a pink cube is outside of the game view, on became invisible is called. When it comes back in the camera angle, on became visible is called. But hiding behind another object doesn't call the function, because since the pink cube is in the camera view, then Unity calculates it and draw the white cube in front of it. So those functions are only called when objects are outside of the camera view. Then gizmo rendering is useful for debugging since the gizmos here will be only shown in the editor in a scene view. Let's add a yellow sphere in the editor scene. The sphere isn't visible in the play mode. If a pink cube is added to the scene in the same position, you can see the yellow sphere more dramatically. In the scene view, yellow sphere, which is bigger than the pink cube, is visible, and in the game view, only the pink cube is visible. Then GUI rendering is in the cycle, which is useful for debugging. This button is only visible in play mode, not in your actual game build. Clicking this GUI button will write the debug message written in the code. Then another coroutine function, yield wait for end of frame is called. Then on application pause is called. To check this function in the editor, run in background in player settings should be disabled. Then whenever Unity loses its focus, so when the other applications are clicked, the function will be called. Then Unity handles decommissioning. Here belongs on application quit, on disable, and on destroy. On disable is called when a script or a game object is set inactive. On enable will be called when it is enabled again. Then on destroy is called when the game object is deleted from the scene, so destroyed from the scene. Here you can see on disable and on destroy is called in order when you delete the cube. Then when you quit play mode or application, then on application quit is called. You can see the event functions are called in application quit, on disable, and on destroy order. So that was almost all about Unity lifecycle. If you understand them properly, you can write more efficient code with less errors. So if you liked my video and found it useful, Don't forget to press like and subscribe my channel. See you in the next video.